Hello guys, I would like us to look at how to evaluate the following question. This is a double integral with the region defined by the region that's bounding. This is y is equal to 8 and y is equal to 4 plus x squared. Now, we've not been given the limits, so basically what we're going to do, we're going to sketch the region, and then the region is going to help us define the limits. So we're going to start with a sketch. Now, y is equal to 8. This is obviously a straight line. And y is equal to 4 plus x squared. This is a curve. So when we are coming to sketch, for the straight line, it will be obvious. For the curve, we're going to look for the x-intercept and the y-intercept. So the x-intercept, this is when y is equal to 0. So if you replace y with 0 in this equation here, you'll have 0 plus 4. 0 is equal to 4 plus x squared. Solving this is going to give a complex number. Hence, the x-intercept is not there. It's not a real number. Then we go on to the y-intercept. So the y-intercept, this is whereby x is equal to 0. So if we replace the value of x with 0 here, what we are going to have is y is equal to 4 plus 0. So we're going to have y is equal to 4. So the y-intercept occurs at the point 0, 4. And then let's look for the turning points of the curve. Now, in order for us to get the turning point of a curve, we get the gradient because we know that at any given turning point, the gradient is supposed to be 0. So differentiating this to get the gradient, we'll have 0 plus 2x. We equate this to 0 and solve, and this is going to give us x is equal to 0. So at the point x is equal to 0, what is the value of our y? If you replace x with 0 there, you'll get y is equal to 4. So the turning point occurs at the point 0, 4. This is whereby we have our turning point. So let's come and do a rough sketch of this particular region here. So having this as our x-axis, this as our y-axis. So this is just a rough sketch. X-axis, y-axis. Let's have this as our 0.4. Let's have this as 8. Now, we need to determine, is it a minimum point or a maximum point, the turning point? So in order for us to know that, we come and get the second derivative, d2y dx squared. So differentiating 2x, we get 2, which is greater than 0. Hence, this is a minimum point. So coming back to our sketch, since we've already established that it's a minimum point, the curve is going to go this way. It's supposed to be smoother than this, but this is just rough. Now the point, if this is 4, I've said this is 8, the point y is equal to 8, it's going to be a straight line going through like that. So the region that is defined there is basically this particular region here. So having defined this region, then it's going to help us be able to know the y limits and the x limits. So we start with y limits. Now, in order for us to get the y limits, we're going to draw a parallel line passing through the region parallel to the y-axis. And then we're going to look at where it enters the region and where it leaves the region. Now, it enters the region here. If you draw any parallel line, parallel to y that's passing through the region, you will realize that it is entering through this, and that is going to be our lower limit. So our lower limit for this is going to be y is equal to 4 plus x squared, because it's this curve here, y is equal to 4 plus x squared, and then this is our y is equal to 8. Now, where is it leaving the region? It leaves the region at all times. Any parallel line will leave the region with, at this point, y is equal to 8. So our upper limit will be y is equal to 8. Okay, then now we need to find the x limits. So x limits, this will be found for all the values of x that will enclose all the parallel lines drawn through the region. So if I was to draw parallel line parallel to x through this region, those values of x that will enclose. Now, if I am to draw just practically, the values of x that's going to enclose, going to be here and here. Those are the values of x that encloses this region, maximum and minimum value that enclose this region. So in order for me to find this is obviously the point of intersection of these two curves. So in order for me to find point of intersection, I'm going to equate these two curves. That's going to be the point of intersection. I'm going to equate the two curves. So y is equal to 8, y is equal to 4 plus x squared. Equating them, I'll have 8 is equal to 4 plus x squared. Then this gives me 4 is equal to x squared. So solving this, I have x is equal to plus or minus 2. So my lower limit will obviously be minus 2 and my upper limit will be positive 2. So coming back to our question here, so we're going to rewrite the region, double integral. So we're going to have x squared y squared plus 4xy, differentiating with respect to y and then with respect to x. Now, what are the limits for y? So we're going to write our limits now. So the limits here, we found them to be y is equal to, so y is equal to 4 plus x squared, and the y is equal to 8. And for x, we found -2 and 2. Then we go ahead and now integrate. So we're going to start with the inside part. We're going to first of all integrate with respect to y. So integrating this function, x squared y squared, that's going to give us x squared y cubed over 3, plus integrating this, that's going to be 4xy squared over 2. And then the range is from 4 plus x squared and then 8 over here. Then we have all that, and then we have our dx here, integral from -2 to 2. Okay, fine. Since we integrated with respect to y, we will be replacing these values where there's y. So we will have integral from -2 to 2 of x squared, where there's y, I'm going to write 4 plus x squared cubed, all this divided by 3, plus this can cancel with this so that we have a 2 here. So 2x into 4 plus x squared, and then you have this squared, minus, then now we replace the values with 8, okay? So all this minus, replacing with 8, we are going to have x squared, then 8 cubed, all this over 3, plus 2x 8 squared, okay, dx. Okay, actually I've done it the other way around. This is we first of all start with the upper limit. Sorry, we first replace the upper limit. So we'll have x squared 8 cubed over 3 plus 2x 8 squared. Okay, then minus, we now replace the lower limit. So that's going to be x squared into 4 plus x squared cubed over 3 plus 2x into 4 plus x squared. And then we have our dx. So note that. Upper limit first minus lower. Okay. So evaluating this, so this is going to be integral from -2 to 2, 8 cubed, that's going to be 512 over 3. Then we have x squared plus 8 squared, 64 times 2, that's going to be 128x minus Okay, so we have a whole cubic function, it's cubed there, minus, so we have a long one here, so I'm going to have our x squared here, then evaluating this, so this is going to be, we can use a binomial theorem to evaluate this. So we have our over 3. Let's write the 3 here. Then this is going to be 4 cubed plus 3 into 4 squared. Then we have our x squared right there. Then plus 3, 2. Then we have 4. Then we have x squared raised to power 2. All this divided by 2 factorial. Plus 3, 2, 1. Then we have our 4 raised to power 0, x squared cubed, all this divided by 3 factorial, plus, so this is just this bit here, and all this is supposed to be multiplied by this. Then we have this over here. So plus 2x into, opening that up, that is 4 squared plus 2 into 4, then multiplied with x squared plus 2 into 1, 4 raised to power 0, x squared raised to power 2. All this divided by 2 factorial. Okay, so this basically gives us, so this is long, so we're going to have integral from -2 to 2, 5, 12 over 3x squared plus 128x minus, so opening this up, this is going to be 4 cubed, that's going to be 64, so minus 64 over 3x squared minus, because of this here, so this is 4 squared, that's going to be 16. 16 times 3 divided by 3, so that's just going to be 16. So 16, and our x is now raised to power 4. Then minus again, so 2 factorial, go 2 factorial, then you have 4. 3 will go with 3, so you'll have 4 x raised to the power 4, and then this x raised to power 6. Then we are here now, we have minus again. So minus 3 factorial will go with 3, 2, 1. 4 raised to power 0 is 1, x squared. So this is will be x, so this will be x to power 6, x to power 8 over 3, x to power 8 over 3 minus, so this minus still acting here. So 4 squared, that is 16 times 2. So we're going to have minus 32x minus 16x cubed minus 2x raised to power 5 minus 2x raised to power 5. Wow, that was long. And all this, and then we have dx. So now we're going to integrate with respect to x finally. So we have dx over here. So now integrating that function, so we start with 512x, so that's going to be 512 over 3, x raised to power 3 over 3 plus 128x squared over 2 minus 64 over 3x cubed over 3 minus 16x to power 5 over 5 minus 4x to power 7 over 7 minus x to power 9, 3 times 9 minus 32x squared over 2 minus 16x to power 4 over 4 minus 2x to power 6 over 6. And we evaluate this from -2 to 2. Then you get our answer. So the rest you can just input the values in the calculator.